All right, let's dive into one of the coolest and honestly most elegant ideas in all of AI, the actor-critic method. It comes from the world of reinforcement learning, and believe me, it has completely changed the game for how machines can learn. We're going to break down exactly how it all works. So, to really get a handle on actor-critic, we're going to lean on this one simple but perfect analogy. Just imagine an AI that doesn't just learn by trial and error, but has its own dedicated coach right there with it, giving feedback every step of the way. How would that even work? Well, that's the big question we're here to answer. And here's our game plan. First, we'll set the stage with the big problem in reinforcement learning. Then we'll introduce our all-star team, the actor and the critic, and see exactly how they talk to each other. After that, we'll look at how the team has gotten even better over time, where it's absolutely crushing it in the real world, and what it all means for the future. Okay, so first things first, the reinforcement learning puzzle. You see, before you can really appreciate just how brilliant this actor-critic solution is, you gotta understand the problem it was built to solve. And it's all about this quest for the perfect strategy. At its core, reinforcement learning, or RL, is just about learning by doing. You have an AI agent, kind of like a player in a video game. It takes an action. The world around it gives back either a reward, like points, or a penalty. The agent's one and only job is to get the highest score possible. Sounds simple, right? But mastering it is, well, it's incredibly tough. Now, what's really fascinating is how people first try to crack this nut. There were basically two big schools of thought. On one side, you had the thinker. These are the value-based methods. They try to figure out how good is it to be in this situation. But they kind of fall apart when the choices get complicated, like trying to control a robotic arm with a million possible movements. Then on the other side, you've got the doer, the policy-based methods. They just try to learn the best action, period. The catch? Their learning can be super chaotic and unstable. It's like they're just guessing wildly and only getting better by sheer luck sometimes. Both are smart ideas, but each has a major flaw. And that, right there, brings us to our next section. It's time to meet the actor-critic duo. This is where a hybrid hero is born, designed to take the best from both of those worlds. Yeah, the real breakthrough happened when someone finally asked, hey, why do we have to choose between the thinker and the doer? The whole beautiful idea behind actor-critic is, what if we just combine them? What if we get their strengths to cancel out each other's weaknesses? And this is that team. It's brilliant. You have two specialized parts working in perfect sync. The actor is our player. It's the one on the field, in the moment, making the moves. It's the decision maker. And then you have the critic. That's our coach. The coach is on the sidelines, watching everything the actor does and judging the plays. The coach doesn't make the moves, it just provides that crucial feedback. It really is the ultimate AI partnership. So, how does this AI dream team actually work? It all boils down to their feedback loop. This is the secret sauce, the way the team actually trains and gets better together. Okay, so the whole learning process is this constant cycle. Step 1, the actor, our player, makes a move. Step 2, the critic, our coach, watches what happens. It sees their result, the reward. Then comes step 3, and this is key. The coach gives feedback. In the biz, it's called the TD error, but you can just think of it as a surprise score. It's the coach saying, whoa, that turned out way better or way worse than I expected. Based on that surprise score, the player updates its game plan. And at the exact same time, the coach is also learning, getting better at predicting outcomes so it can give even smarter feedback next time. It's this amazing upward spiral. So this is the heart of it right here. The actor isn't just learning from raw points, it's learning from the surprise in the coach's feedback. If a move leads to a result that was way better than the coach predicted, that move gets a huge thumbs up. If it was a letdown, it gets discouraged. This makes the whole learning process so much more focused and stable than just blindly chasing high scores.
But of course, the story doesn't just stop with the basic model. Like any great team, this dynamic duo had to evolve, going from a promising rookie concept to a squad of seasoned pros.
Over the years, researchers have come up with all these advanced coaching strategies. You've got things like A to C and A3C, which give the coach a smarter way to judge plays. There's DDPG, which is a specialist built for things with super precise, continuous movements, like a robot's joints. And one of the most popular ones today is PPO, which is all about stability. It's like the coach saying, okay, easy does it. Let's not make any crazy changes to your strategy overnight. So, where has all this training and evolution gotten them? Let's take a look at the team's absolutely incredible winning record, which has taken them from playing old school games to powering complex, real world robotics. I mean, the applications are just staggering. This player coach AI has achieved superhuman skill levels in classic Atari games, and even the incredibly complex game of Go. It's the brains behind robotic arms that can learn to do things humans find tricky. It's being used to fine-tune how self-driving cars behave, to create trading strategies for finance, and even to manage the resources in those giant cloud data centers. The impact is absolutely real, and it's happening right now. All of this really points to the future of machine learning and helps us understand why this actor-critic duo is such a complete and total game changer. So if we boil it all down, what's the big takeaway? Well, these actor-critic systems cut down on the noise and chaos during learning, which means they get to a good solution more reliably. They're way more efficient, they learn faster with less trial and error. And because of that hybrid design, they are incredibly flexible and can be scaled up to tackle a massive range of problems. They really are the best of both worlds. So I guess that leaves us with one final and really exciting question. What's the next grand challenge for this AI team? From discovering new medicines to managing our planet's energy grids, what huge complex problem out there is just waiting for this player coach AI to come along and solve it? Now that is an exciting future to think about.